Okay, so we're going to do proofs about angle pairs and segments. I'm going to skip that initial example in the notes and go straight to the three theorems for today. We have three of them. First one being the right angle theorem. So if two angles are right angles, then the angles are congruent. Same supplements theorem. If two angles are supplementary to the same angle, then the angles are congruent. And same angle complements theorem. If two angles are complementary to the same angle, then the angles are congruent. All right, let's do the proof of the right angle theorem. I'll give the statements first, and then you're going to probably want to pause it after that, and then see if you can come up with your own reasons. Okay, so statement number one. See, angle A and angle B are right angles. Statement 2, the measure of angle A equals 90 and the measure of angle B equals 90. Line 3, then the measure of angle A equals the measure of angle B. And 4, angle A is congruent to angle B. So, pause here and see if you can come up with your own reasons. Here are the reasons. First one, that's given. Line 2, that's a definition of a right angle. Right? Right angles, by definition, are 90 degrees. Step 3, that's actually going to be the transitive property of equality. Of just line 2. And 4 is congruent objects. Which basically says that if objects are congruent, they have the same measure. And vice versa. All right? Next proof. Proof of the same angle supplement theorem. This is relatively the same as the proof of the same angles complement theorem. Really what would only change would be that instead of 180 degrees, you change it to be 90. And instead of using definition of supplementary angles, you use definition of complementary angles. But again, I'm going to give the statements. You're going to want to pause, see if you can come up with the reasons yourself, and see whether or not you match with what I have. So, first statement, angle A and angle B are supplementary. Angle B and angle C are supplementary. Number 2, the measure of angle A plus the measure of angle B equals 180. The measure of angle B plus the measure of angle C equals 180. Three, the measure of angle A plus the measure of angle B equals the measure of angle B plus the measure of angle C. 4, the measure of angle A equals the measure of angle C. And 5, angle A is congruent to angle C. So you want to pause it here so you can come up with the reasons yourself. So first one, that's given. Line 2, that's definition of supplementary angles. Line 3, that's going to be the transitive. Property of equality. And then from 3 to 4, you notice that the measure of angle B disappears because we actually subtracted from both sides. So the subtraction property of equality occurs, and then we have congruent objects. Saying that objects of same measure are congruent. The next proof we have is for vertical angles theorem. Remember that vertical angles are congruent. So here we have some of it filled out. I'll again just complete the statements and then see if we can finish it up doing the reasons. So line 1 here, lines K and M intersect. Then for 4, we have the measure of angle 1 plus the measure of angle 2 equals 180. And we have the measure of angle 2 plus the measure of angle 3 equals 180. Line 5 has the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And line 6 has the measure of angle 1 equals the measure of angle 3. Let's take a look at the reasons. So you're going to want to pause here and see if you can fill out the reasons yourself. Alright, so reason number 1, that's given to us. Number 2, where it states that angles 1 and 2, 2 and 3, 3 and 4 are linear pairs. That's the definition of a linear pair. And then line 3 is the linear pair postulate. Right, that's what LPP stands for, linear pair postulate. That allows us then to say that the measure of angle 1 and 2 sum to 180, and measure of angle 2 and 3 sum to 180. Transitive property of equality. States that we can say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And then from 5 to 6, they subtract the measure of angle 2 out. So they use the subtraction, POE. And then because those measures are equal, we can then say that they are congruent by congruent objects. All right, let's do this next example here. So given angle 1, angle 2, and angle 1 and angle 2 are congruent, and angle 3 and angle 4 are congruent, we need to prove that angle 1 is congruent to angle 4. I'll tell you right now that this proof, it has 5 lines. First one, is angle 1 is congruent to angle 2. Second line is angle 3 is congruent to angle 4. Once we've got that, we can say that angle 2 is congruent to angle 3 because they're vertical angles. And then we can now say angle 1 is congruent to angle 3, and therefore angle 1 is congruent to angle 4. All right, give it a pause right now and see if you can figure out what the reasons are. All right, so what are the reasons here? We know line 1 is going to be given, and line 2 is going to be given. Line 3, if you were listening, I said they were vertical angles. So VAT vertical angle theorem says that they are congruent. So 1 and 3, angles 1 and 3 have to be congruent by the transitive property of congruence. We're going to take line 3 and plug that into line 1. Now we can then say for line 5 that it's transitive, again, property of congruence. And we're going to plug in line 2 into line 4, which then allows us to complete this proof. All right, this next one is a lengthier proof. It's going to have about 10 steps to it. All right, so I'm going to list out what those steps are, and I'm going to have you guys see if you can determine what the reasons are then. All right, so first line, ray BF bisects angle ABC. Line 2, the measure of angle ABF is equal to the measure of angle CBF. Right, the reason for that would be definition of angle bisector. Line 3 says now that the measure of angle ABF equals the measure of angle ABD plus the measure of angle DBF. By the angle addition postulate. Also, line 4, which is very similar, says the measure of angle CBF equals the measure of angle CBE plus the measure of angle EBF. Again, by angle addition postulate. Line 5, here's where it gets really long. The measure of angle ABD plus the measure of angle DBF equals the measure of angle CBE plus the measure of angle EBF. Line 6 is our next given piece of information. Angle ABD is congruent to angle CBE. Seven then allows us to say the measure of angle ABD is equal to the measure of angle CBE. That's congruent objects, have congruent measures again. And then in line 8, the measure of angle ABD plus the measure of angle DBF equals the measure of angle ABD plus the measure of angle EBF. So very subtle change happening here that we have to be very careful about in line 8. I'll be a little bit more careful when I go over the reasonings for that, all right? Line 9, the measure of angle DBF equals the measure of angle EBF. And then our last line, angle DBF is congruent to angle EBF. So go ahead, give it a pause here, and see if you can figure out what the reasons are. All right, line 1. That one is given. Line 2, definition of angle bisector. Remember, an angle bisector splits an angle in half. And 3 and 4 are both angle addition postulates. That allows us, when we say this allows us then to justify that. Line 5, we can then substitute or transitive, lines 3 and 4, merge them together, plug them into 2. Six is given. Seven is congruent objects, have congruent measures. 8, now 8 is where we have to be very careful. We're going to take, if you notice, look at the line 8 and compare it to line 5. There's going to be a substitution that occurs of line 7 into 5. So 9, we then have 2 of the same angles on both sides, so we're going to subtract them. And then 10 is congruent objects. All right, and that's all the examples I'll be covering today.